Hello, my name is Alexey Ulyenkov. This is Vladimir Ozerov. We're the leading Sberbank online developers. And today we're going to tell you what core data storage we use in Sberbank Online. We'll explain you the reason we decided to select it, the way we get there. As you can see, that it's very different from what Apple gives you out of the box. Okay, what are we going to talk about? We are a new, young, rapidly developing country that is 175 years old, and I'll show you the way we are growing up in the field of iOS developments. We will tell you what are the extendable models are, what do we need them for. We'll show you some examples and applicable examples and how to practice extensively the way we can actually cover that using integration tests. Now we'll tell you about the way we are developing. In 2008 our team consisted of 5, in 2016 we had like 2012 like 24, and then we're going to have something like 80 people for iOS. We have 80 for Android development, and it's working in this or that way where we publish releases, and it's quite a challenging task to do. In principle, it is important to note why do we use this type of architecture? It all depends on the way team management process is aligned. We have Sberagile, that is adjusted Scrum. It's like a story about the thing that we have a team that is able to do the end-to-end delivery. It actually has the product owner and actually is stuffed with all these engineers who make the backend, they make the design, Android, iOS, and do the testing. This team can do the full feature from end to end. It would have been logical to make such an architecture that will enable the teams to do the independent development without any effect on each other, so making a type of a sandbox. Okay, for example, for the CocoaHeads, we actually discussed this Sberbank online architecture. Now I'll briefly mention what it is and the way we do it. This presentation is a logical continuation of the previous one. We have a type of basic set of frameworks and services that provide our consumer, and we are as a team busy with the infrastructure part. We make the components that are used by all different groups and teams. That is a set of services and helpers that we provide our customers and clients with. We also have specific base components, it's like the middleware. It's not a core component, but still it's not like a business essences that do not implement business features, but enables us to make some important features for the customer, like payments, transactions. We get a lot of transactions. It's like a business feature. On the other hand, it's like a middleware because it gets a lot of consumers and clients. Sberbank application in runtime, this application collects all the business working instances and contains all the integration points like toggling based on this Sberbank app. So the application compilation and the business feature set that is distributed as dynamic frameworks. Also, Sberbank shifts from legacy systems to the unified front system. This is our core development that enables us to render a unified experience in all the networks, platforms, and services. This architecture enables us to smoothly migrate between different types of backend and switch from legacy systems, that is, disconnect obsolete models, connect new ones, thus ensuring the migration. We need a type of storage that will operate. We know we have a lot of frameworks, and these frameworks shall contain some type of model components. Now we'll tell you a bit about the core data stack. It consists of a large number of essences, that is, business storage, story coordinator, context. But in these presentations, we won't be able to cover all the feature set of our stack implementation. That is why we will concentrate our attention on the model forming and generation, as model is the key element. the way we're going to create the model, separated model that is combined of different models, as every model implements the whole business features. That is why we have all the essences, all the links, and all the interconnections it adds. Let's look at what model is made up in the core data. So that is the MS management object. It's like a container that contains the essences that predefine the model structure. The main essence is the MS management description. If we just link an analogy with the SQL, that is the tables in the database. The second essence in core data is the MS property description that makes up the corresponds to the columns in the table. Then we add up links. In core data, we just use MS relationship relation. It may be one-to-one, one-to-n, n-to-n, and one requirement of core data is that these links shall be in pairs. One of the important specifics of core data is the configuration. We do not use classes, but we differentiate them based on the dictionaries of MS and S management object. It adds unique features to the core data. That is, we can actually divide all the essences set to configuration. We can use overlapping configuration. We can also set to every configuration its own data storage. For example, for configuration 1, we will use SQLite. That will be in the file systems. For the second configuration, we're going to use the binary storage. For the third configuration, we're going actually to store everything in the memory without any caching. So our stack enables us to operate and manage configurations like a standalone model using business feature, where you can actually make an independent configuration without any link and its own storage. But we won't be able to describe that in our present presentation. Furthermore, we're going to switch to hypothetical tasks. For example, just let's imagine that we have like an imaginary stories like costly bicycling, cycling. It's just based on a well-known cartoon series. We have a list of characters, of negative characters, princesses, and the ownership in the state. So actually, the developers got together and they decided to make this database. This is the main one. We actually added the abstract essence, like so it has the character with name and portrait. That is the image. Then we added consistence of string, that is the princess. And if somebody watched this movie, you just know that they are made of different materials. That is, we just made like an essence made of or consists of string. Then we have the ADVMO hero, that is feature. It has string. It's like the feature, a type of attribute. Then we add up another essence. This is the bat hero. It has a superpower. Then we add up, a kingdom. We can see that it has like a one-to-one relation with the princess. That is, the princess runs the kingdom. And we also add up another essence. That is the dwelling place. We have the location property. We made one-to-one relation with the bad hero, bad guy. Let's just believe that in one dwelling, only one bad guy can live. And in one housing can accommodate, like a multiple number of heroes, like we can think. So, we had an application like this, using this model. So a programmer comes and says, let's give our fans an opportunity to produce their own extensions that will be like a dynamic library, and fans will not have the ability to change the core code of the application, but they will be able to, add something new. That is why the fans want to make a multi-universe. We have our old model, the one we used in our application. Now we're going to extend it. What are we going to do with this? We add up objects, the universe, that will have one-to-n relation with the characters, with the kingdom, with the dwelling place. We add up one another property from the outer hero for the bad guy. It can be an alternative hero in this universe, and we have the genuine character that has several alter ego in the multi-universe. That is why we have a one-to-n relation. Now let's talk about the limitations we give to the fans who are going to develop their own extensions. First of all, we develop the main application. The fans make extensions. Fans do not have the right to change the main application code. Architecture. We have a framework core data that we produce ourselves that actually implements the core data and has no business features. However, it has all the set of the required helpers to create the extendable model. We have UDB core, we also produce it. It has the business features, and we actually implement the first model we have, and I show you. We have an application that actually combines and compiles this application in the runtime. So we have the current application with extension, and the framework fan multi-universe that is produced by the fans that has business features and that contains the extendable model. Now we will talk about the construction of a model. So the way it's going to take place in our application. We will actually split it up into several stages. First of all, we need to predefine what models will take place in forming the model, because the actual models can present a great many of them, and not every one of these models can be or shall be changed or extendable. Then we need to predefine the interdependencies. In our example, it is absolutely clear that the fan model of the multi-universe requires the presence of the model it will change. That is why it will depend on this model. Fan model will be dependent on the core model. At the second stage, we need to generate the full list of all the essences with all the properties. We actually do this in all the models. At the third stage, we actually add up the links and dependencies between the essences. At the fourth stage, we actually predefined what essences are inherited from another ones. There is an example of a hero or a character that actually gives the heritage to all other features and models. Let's now actually consider different models. We will just present and unite different models. We have the protocol runner, and in order for us to predefine what models are used in the runtime, we use the runtime in GC7, and we predefine the list of all the loaded classes, and we actually define which ones of them execute this type of protocol. So we have the list of classes, but then we need to predefine and identify the interdependencies. For that case, we have two different parameters. First of all, this is the ID model property. The second one is the list of all the IDs required for the model. Based on all these two parameters, you can actually identify with the 100% surety rate the list or the set of the required models and their interdependencies between them. As a result, we have this array, this model. So the 0 index has the ADV core, and index 1 is fan multi-universe. The second stage is actually the compilation of the essences. Let's continue this example. We have a character or hero. It's like an abstract one. We create the NS object class, and it implements this protocol. It has the property, name and portrait, and the generation itself of this essence model is performed by using this method. In our SDK, we do have some helper methods that helps us a lot by decreasing the amount of code. Otherwise, we would have had to create all the instances and descriptions manually. But here, we can use the automated and flexible helpers. You can easily see here that we create two properties with the name type, and we add everything into the essence. It just identifies that it's an object essence. It's absolutely logical that we use this code to set and assign different essences to all the different code elements for all our objects and models. Then, when we have all this, when we have created all the entities, we can easily add different links and interdependencies into relations. Let's just look at the three object group. That is the hero, the bad guy, and the dwelling place. We have one-to-one and one-to-n relation. In the interface, we're going to have the properties like this. And we have specific method, Boolean entity. For example, here we can actually use an entity like a meta model. And in order for us to create an S object, we need to have everything ready. We just cannot generate it gradually, slowly. That is why, first of all, we have to gather together all the objects in a type of meta model, and then all the entities we have created and generated together in the previous stage, we get all of them into the meta model. And at the entry point, we submit all the list of entities. We just pull it out from the meta model, that is the entity of the dwelling of the alien, and we can actually combine and link them together. We use specific helper function features that reduce the amount of code we need, and we add different interdependencies and links. We add the name, the link or relation type, and we also create the pairs, as this is the core date requirement. The last stage is actually defining the heritage. It is not logical why it's the last stage, because we should have made it at the level of the entity creation, but in the reality, it's predefined by the core data. Should we add it earlier at the previous stages, then the property we added would actually duplicate and replicate in all other entities that are inherited from some type of objects. That is why we shall bear in mind this peculiarity. You can see here we have a different method to introduce these sub-relations. That is why we pull our entity from the meta model, that is the character, the princess, the villain, or the hero, and we just link them all together. Everything is absolutely simple. Now, let's look at the way it works in a dynamic process. For example, let's presume that we have finished the first stage, and at the entry stage we have two models, ADV core and file multi-universe. The first stage, we need to compile the entities. Just let's remember that we have an incomplete set of entities. We only have the main ones. We perform this stage for the second model, and we have the entity as the universe. In principle, should we have more models here, then we would have performed this stage and applied them to all the models and all the entities. Then we actually do the second one, linking. We add links. First of all, we just apply this tool for the first and then to the second model. And the final stage, we add the inheriting parameters for the first and for the second model. We do not have any inheriting for the fan multi-universe. That is why we do not apply this method to this part. It looks like this approach is very flexible, but at the same time it has specific trade-off. We shall bear in mind. You have all seen and know that we need to enter the whole model or BD model, database model through the code. You cannot just look at the design and make a fast assessment the way it looks. You have code only, nothing more and nothing else. And the outcome is the requirement to implement the versioning of different business components. For example, if we have a model from a higher level and then we lose one of the entities, then most probably one model below, like say fun multiverse, it will throw an exception. At the same time, as the main benefit, we get an independent development within one application by different teams. That is one of the reasons we've decided to go for this approach. And as a bonus, we get an opportunity to make a flexible business component management at the runtime stage. We can do the beta testing and alpha testing, activate and deactivate different features, and you can actually assemble this model, compile the model in absolutely any case, in any view, and any time. In order for us to make sure that we operate and use all these features correctly, that is why we do a comprehensive set of different tests like unit tests, integration tests, and I'll tell you what we need them for. The integration task can be broken up into two groups. The first one is just the ones who verify the data integrity. In principle, this actually protects us from the cases when we make different minor insignificant changes, or if, for example, something happens with the iOS when a new iOS version is released. But as we have an integration test, then of course we need to introduce an entity that will enable us to do the feature test. And in this case, we have a set of protocol that enables us to perform two things. The first one is actually to populate the database with objects, and the second method is to verify the consistency of data in the database. In this case, the integrity data test is just performed that we initialize the database, we make a model populated with data, then we destroy our stack completely, we purge it, but at the same time we have the cake. Then we rationalize the stack, then we check the consistency of data. This protocol is implemented and executed not by one element, but a set of models describing different database models, a set of links, of entities, and in this case we get a complete set of different scenarios for this specific task. This is a very simple task. This is the base verification check you need to do. The second option is a bit more complicated, is when we perform the data migration. In the system we execute, we actually provide our developers from all different teams, well, a free approach to modifying database. We do not limit them in any case. And with a high probability level that strives to reach 100%, all the following updates, our database model will be changed. If somebody is aware of core data, then you know that data migration can actually be indicated in the code. We use our property mechanism. We cannot actually explain about this mechanism because there are a lot of interesting and exciting things, but the time is limited. But we can say a few words about testing. For this purpose, we decided to extend the protocol from the previous slide, and we added one thing. Now we have the type that actually sets up the model view or middle type. We actually affix or appoint a standard model and add up modifications and adjustments. The first modification is actually a decreased or shrinked model. For example, we just reduced some entities, some links, some properties. The second option is an extended model. It's like when we add something to it. The option 3 is actually when we add something, we reduce or remove something from the model. And the last option is actually when the model is absolutely different and we have nothing in common or no relation in between the previous ones.
And in that case, the test is equivalent to the previous one, but this way we are running an iteration. It will be a 2 times nested cycle, and we test how the migration will be executed from each type to the same type. So it will be like 1-to-1. Here, it's not so transparent that we need to extend this and add another method. I mean the consistency check. In that case, we need to have some metadata just to check whether these particular data are correct after the migration being performed. So let's have an example. For example, we run a migration from shortened version to an extended version. Then our check would not be run correctly because it would think that those entities appeared they need to contain some data as well, but they were not in that shortened version. That is why we need to know this information. And a couple of words about Swift. Well, basically, this can be used in Swift, but as we are using a lot of Objective-C runtime, this needs to be implemented in Objective-C. You can see our source code at GitHub. Just follow this link. Also, you can ask our. So this source code is just without UI. It's the example that we have presented to you. Now we're ready to answer the questions. So, as far as I can see, the presentation is over. Now we are proceeding with the Q&A session, and we'll have a special prize for the best question. As I understood it correctly, any developer in your team can change any model. Does that mean that a developer of a non-core module can change something in the core database? And also, it's not very clear about versioning and support. So if, for example, an additional module was using an entity from core, and if core developers just remove this entity or properties, the tests are down. And who is responsible for this, and how you come up with that decision? Okay, let me take the second one, and you will be answering the first question. So, as for the first question, the answer is the following. We showed it. The problem with the multi-universe is just like what we are having. You cannot change the core model. It can be extended, but not changed. The developers cannot just come and remove an entity. They can extend it. They can add an entity, but not remove it. And one more question about versioning. For example, core data allows you to see the version history, and you are using only source code for it and git log. Is that right? Yes, that's right. As for the second question, and about versioning, basically it's a more high-level question about versioning, not just about a core data particular functionality. If we have a dependency, we expect that there is something in this module. It can be tackled in this following way. Even in Apple, they have duplicated methods, and with the next iOS update, when iOS just thinks that this should not be used, to just flag it as a macros. You can use your own macroses that will use the same mechanism under the hood. And if a developer provides his or her own module, this person can just see that this method is deprecated, and in the next version this will not be working anymore. So if you are provisioning a new module, you are forced not to use deprecated methods. This applies to properties as well, to core data, to entities, and this is how we tackle this. So module is the framework in that way. Yes, when we're talking about module, this is our, let's say, uniqueness. Module is just a framework with the special functionality that we have entitled to. So a bit aside from the main topic, but do you encrypt the data that you store? So apart from the overall container encryption, do you have your own encryption? That's a decent question, because you see, when we were talking about configuration, we said that different configurations can use different CAN storages. And personal data, critical data, we reset them every time. So we do not store them. We just don't store them. For example, as for ATMs, they can be stored in an open way. We need to cache them and to encrypt them. We have huge capabilities in here, but it's a different version. So the functionality is a bit shortened. So you just so no, they are not encrypted automatically and they are not stored. So do you have a cipher, a custom cipher? Yeah, we do have it, but the main idea is that we do not store personal data. We just erase them every time. Got it. Thank you.